Start with problem from linear algebra. So the first problem, suppose A is some 3 by 3 matrix. We have to find A power 50. So the first problem, if A equal to 1 0 0 and 1 0 1 and then 0 1 0. If A is this, then what is A power 50? Okay, so the first option 1 0 0 50 1 0 50 0 1, and then the second option 1 0 0 48 1 0 48 0 1, then third option 1 0 0 25 1 0 and then 25 0 1, the fourth option 24 1 0 0 24 1 0 24 0 1. Now this type of problem they will ask find the highest power of the matrix. Sometimes they will ask A power 100, A power 50 or A power 49, they will ask anything. So first you have to find, there are two methods are there to find the power of any matrix. First you find the characteristic polynomial of the given matrix. Okay, so first you have to find the characteristic polynomial. So therefore what is the characteristic polynomial? P of x is determinant of a minus lambda I. Okay, so therefore this is nothing but determinant of what is A. We have to subtract minus lambda on the diagonal. So already we have 1 in A, we have to subtract minus lambda 0 0, and then this end is 1 and this end is 0, but we have to subtract lambda, therefore minus lambda 1, and then here 0 1, here 0, but we have to subtract lambda. So we have to subtract minus lambda on the diagonal elements of A. So we will get 1 minus lambda minus lambda minus lambda on the diagonal. So we take the determinant of this, that is a characteristic polynomial in lambda. So if suppose this is x, you have to replace x. Okay, suppose I call P of x, therefore we can call P of lambda. Okay, so we can expand via the first column, first row, therefore 1 minus lambda times lambda into lambda, lambda square minus 1 into 1 1. All others are 0, because if you expand this into 0, this into therefore 0. So therefore we get just lambda minus 1. You can adjust with the constant, is not an issue. Okay, so therefore we can simply write lambda minus 1 whole square, because this is lambda square plus 1 is lambda plus 1 into lambda minus 1. So this is lambda minus 1 whole square into lambda plus 1. Okay, we can adjust with the minus, is not an issue. Okay, so this is actually P of lambda. So if we expand this, otherwise simply we can expand this. So 1 into lambda, therefore lambda square, anyway we can directly write this. So lambda square minus 1 is the entry here, and then minus lambda into this minus lambda cube minus minus plus lambda. So therefore the polynomial is, you can adjust with this minus, you can multiply minus, otherwise you can take determinant of lambda I minus a, you will get minus anyway. So you will get lambda cube minus lambda square minus lambda plus 1. So this is a characteristic polynomial. Okay, okay, anyway now we have to find, we have polynomial x power 50. Okay, because we have to find a power 50, therefore we take x power 50. Now apply the division algorithm for this polynomial and this polynomial x cube minus x square minus x plus 1. Okay, what is the division algorithm for polynomial? Suppose f of x is a one polynomial, g of x is another polynomial. Suppose the degree of f of x more than f of x, we can write as a g of x into some quotient, that is q of x, plus some r of x, where this r of x is either 0 or the degree of r of x should be less than degree of g of x. Okay, so therefore we will get this equal to x cube minus x square minus x plus 1 into some quotient. We don't know what is a quotient, we call q of x, and this should be r of x, but r of x degree should be less than this degree. This is third degree, therefore the r of x should be second degree. Therefore we can take any second degree, we can call a x square plus bx plus c. Okay, so this is a second degree polynomial. Now our aim is to find a, b, c value in the remainder polynomial r of x. You have to find what is a, what is b, what is c. You will get a thing. Okay, now if you substitute x equal to a, what you will get? The left hand side we have a power 50, and if you substitute here, actually this is nothing but p of x polynomial, right? This is a characteristic polynomial p of x. If substitute a, we get p of a. Okay, so p of a into r. Okay, anyway you can directly substitute x equal to 1, because 1 is a root of this one, so 1 is a one eigenvalue, and then minus 1 is also another eigenvalue, but 1 repeated 1 times, sorry 2 times. Okay, so therefore these are the eigenvalues 1 1 minus 1 anyway. So you can directly substitute x equal to 1, you will get anything, but anyway, so if substitute x equal to a, we get p of a here. So this should be p of a and q of a, plus here we get a times a square plus b times a plus c times identity. Okay, so we know that this term is 0, because any characteristic polynomial satisfies characteristic polynomial, therefore p of a is 0. So we get this thing, but from this we cannot conclude anything so far now. So what we have to do, okay, otherwise you can directly write that from this the characteristic polynomial satisfies the equation a cube minus a square minus a plus I equal to 0. Okay, but I am saying some simple method, that's why I am, otherwise you can find the Jordan form. If you find the Jordan form, you can easily get the solution. But okay, anyway, there are so many methods. What we can do, first we can find what is a power 4. Okay, okay, otherwise we can do little work. Okay, what we will do, we can, okay, I will explain on some, because it takes time to solve this. Okay, anyway, so before going to this, anyway, we first differentiate this. Actually we have to substitute x equal to 1, because 1 is a root of this polynomial. So if substitute x equal to 1, you will get the right hand side is left hand side is 1 and this is 0, because if substitute x equal to 1, this is 0, and here we got a plus b plus c. So we get one equation, a plus b plus c equal to 1. Okay, now if we differentiate this both side, therefore we get 50 times 50 into x power 49 if you differentiate this is a product of two polynomial. Okay, so first you have to fix p of x and then differentiate q of x, therefore q dash of x, and then fix q of x, differentiate p of x. Now simply writing p dash of x, we have to write what is p dash of x. Okay, now plus here if you differentiate we get 2ax plus b, because derivative of c is 0. Now what is actually p of x? I already said that x minus 1 is a eigenvalue repeated 2 times, and 1 plus 1 is the eigenvalue repeated 1 times. So again if you differentiate this, if you fix x plus 1, if you differentiate this we have 2 times x minus 1, plus if you fix x minus 1 whole square and then differentiate x plus 1, we get 1. Anyway this term contains x minus 1, this term contains x minus 1, therefore if you substitute 1, x equal to 1, you get 0 anyway. Okay, so now substitute again x equal to 1, we get the left hand side we have 50 equal to, this is 0 because 1 is eigenvalue, therefore p of 1 is 0, p dash of 1 is also 0. Okay, so here if you substitute x equal to 1, we have 2a plus b. Now even you can substitute x equal to minus 1, maybe you can call the equation is 1. Okay, so if you we get another equation like this. Now substitute x equal to minus 1, therefore minus 1 power 50 in the right hand side, and again p of x minus 1 is also eigenvalue, therefore p of minus 1 is 0. So therefore this side you will get a square, that is a into minus 1 square is minus the minus b plus c. This is nothing but even number, therefore should be 1. So what you will get, this is another thing, a minus b plus c equal to 1. This is another equation. You can sum these two, we get a plus c should be 2a plus 2b, 2c should be 2, that is 2 to cancel, we get 1. So therefore a plus c should be 1. Okay, and we have a 2a plus b should be 50. Okay, and we have to find abc value. Okay, now if possible we can substitute in the second equation, maybe we can call this is second equation. Now substitute here x equal to minus 1, therefore the left hand side we have a minus 50, and this term again 0 because p of x is there, p of minus 1 is 0. And if you here, okay, but if in the p dash, anyway this term is 0, but this term is, we have a non-zero, so that is not a case. Okay, now from this we have to find a, b, c. So what is the idea I am saying? Suppose you find a, b, c, after that you got to substitute x equal to a, again this term is 0, we get a square plus b a plus c times I. If you know a, small b, small c, you can easily find a power 50 because we know what is a square. You got just to multiply a 2 times, you will get a square. Okay, and then simply will get. Okay, so otherwise we got to do some other thing, little work. So you got to find the eigenvector, and then you got to form the you got to find the Jordan canonical form. That's the thing. Otherwise, okay, but you are all not study that Jordan canonical form. That's why it's taking little difficult. Okay, anyway, you try to solve from this. You have to find a, b, c. Okay, otherwise I will say some other method. Okay, to find. Otherwise, just find a square, a cube, and then so these are even number, right? So a power 50 is even number. So therefore, first you have to find a square. Once you find a square, you can easily find a power 4. Once you find a power 4, you can easily find a power 8, and then a power 16 is just a product of this thing. So from this you can easily find. So up to you can go 48. So 48 is nothing but a power 32 into a power 16. So we can within 5 step or 6 step we can find.
Sir, a plus c is equal to 1 is the equation, sir.
Sorry, a plus?
A plus C is equal to 1 is also a equation, sir.
Yeah. Oh, so then B is 1, right? So, yeah, thank you. So now substitute here, right? So A plus C is 1, therefore B should be 0, right? Yeah, got it. Now if B is 0, now substitute here, A should be 25. Now if A is 25, what about C? C should be what?
Minus 24.
Minus 24. Yeah, that's it. Now if you find A, B, C value, now we find the answer. So now in the first equation, if substitute just x equal to A, the right hand side, left hand side we have A power 50, and this term is always 0 because the A satisfies the characteristic polynomial. Therefore this, if substitute x equal to A, this term is always 0. Don't bother about this term. Okay, so if substitute A, we have A power 50 here, and this is equal to 0 because this term 0, plus now we know small a value, small b value, small c value. You can easily find A square and this is A. So finally we get A power 50 equal to A times A square plus B times A plus C times identity. Okay, so first you got to find A square. So what is A square? So you have to multiply A 2 times. So what is A actually? 1 0 0 1 0 0, sorry, 0 0 1, and then 0 1 0. So that is a matrix A. So if you multiply, we get this term is 1, and then if you multiply, this get 0, and this is 0, and this one is 1, and this one is 1, and this one is 0, and this one is 1, and this one is 0, and this one is 1. Okay, so this is a square. Now that's it. You know what is the values of A, all the things. Now we get, therefore A power 50 should be A. What is A? 25. So 25 times A square. So 25 times what is A square? 1 0 0 1 1 0 0, sorry, yeah, 1 0 1. So this is A square. B is 0. Okay, so no need to write A. So plus C, but C is 24, therefore minus 24 times what is A, sorry, identity matrix. So C times identity. Now multiply 25 inside, and then just you can do all the things. So we get 25 0 0 25 25 0 25 0 25 minus 24 0 0 0 24 0 0 0 24. It should be, the diagonal entry should be 1 1 1 because 25 minus 24 is 0, and the above the diagonals are 0 always. Now 25 minus 0, this entry is 25. Again 25 minus 0 is, this entry is 25, and 0 minus 0 is 0. Okay, so got it. Therefore the last first column should be 1 25 25. That is the answer. Yeah, the C1. C is the correct answer. Okay, so any doubt in this?
No, sir.
Okay, so this is the idea. So the simple idea. So you can apply the division algorithm and then find a ABC. So if possible, we will see one more problem like this after some time. Now we solve one more problem. Second problem from linear algebra. Suppose T is a linear transformation from some field F2 to F3, or simply say R2 to R3. Is a linear transformation is defined to be T of, if you take any two element x comma y, goes to the order triple. The first coordinate is just x. The second coordinate should be x plus y, and then the third one is just y. This is a linear transformation. Now question is, what is the nullity? Then the nullity of T is, then nullity of T is, first option is 0, 1, 2, 3. So what is the guess? What is the kernel? Kernel means what? The null space, set of all x, y such that T of x comma y is 0. So therefore should be what?
0, sir.
Yeah, 0. Because the null space of T, if you write the definition of null space, is set of all ordered per x comma y such that T of x comma y is 0, 0, 0, 0. But by the definition of T of x comma y is nothing but x comma x plus y comma y, this should be 0 comma 0 comma 0. So that means x equal to 0, y equal to 0. Therefore it contains only 0 comma 0 vector. So this is a 0 subspace. For 0 subspace, the dimension is always 0. Okay. So therefore nullity should be 0. Okay, good. Next, we solve some question from algebra. Third question. The number of 5 silo subgroup. The number of 5 silo subgroup or subgroups depending upon the answer. In the group of order 45, in a group of order 45 is, so the first option is 1, second option is 2, third option is 3, fourth option is 4. How many 5 silo subgroups are there? And we know that by Silo's third theorem, the number of 5 silo subgroup is 1 plus 5k. Okay. So the number of 5 silo subgroup is 1 plus 5k. Is of the form 1 plus 5k. We got to specifically find what is the values of k. If you know the k, substitute here, we will get the answer. So actually you can easily guess the answer now. Should be, the answer should be multiple of 5 plus 1. Okay. Anyway, the number of 5 silo subgroups is of the form 1 plus 5k for some k. Therefore the options are, we got to look at the options. So answer should be multiples of 5 plus 1. That is maybe 6 or 11 or 16, like that. These are all multiples of 5 plus 1. Right. So in these given options, we can, if you take k equal to 0, we get 1. So we can simply see this is the correct answer. Because 2 is not of the form 1 plus 5k for any k. Again 3 is not is of the form 1 plus 5k. Okay. Again similarly 4 is not is of the form 1 plus 5k. Therefore simply we can say 1 is the answer. But why is 1 is the answer? By if you look at the theorem, we know that this number 1 plus 5k divides the group order. So group order is 45. But 45 can be written as 3 square, that is 9 into 5. And we know that this number 5 and 1 plus 5 GCD is 1. By well known number theory result, we have 1 plus 5k divides the remaining number 3 square. But we have to find 3 silo subgroup also. Okay. So now what are the possible for 5 silo subgroup? The divisor, this number divides 9. Therefore either it can be 1 or 3 or 9. So we cannot get 3, because if you substitute any values of k, we cannot get 3. What about 9? Still 9 also, if substitute k equal to 0, we get 1. If substitute k equal to 2, we get 11. So So you never get 9 for any values of k, but you will get 1 if substitute k equal to 0. Therefore we have a, so directly we can get, we have only one 5 scalar subgroup, the number of 5 scalar subgroups 1. So that is answer. Sometimes you can directly guess the answer. So the answer should be is a multiple of 5 plus 1. So but in the option we have only 1 is the multiple of 5 plus 1, all others are not. That's why we can say. Otherwise quickly we can find this one. Okay. Now the next one. Go the next year. Again they will ask the minimal polynomial and then the characteristic polynomial. Okay, so but you are not studied about what is minimal polynomial, all the things, so I leave it that one. So I already discussed about minimal polynomial, right? So minimum degree, and that should satisfy the matrix. Such a polynomial is called minimal polynomial of a matrix. Okay. So anyway, now we solved another algebra problem. The number of elements of in the conjugate class of 3 cycle in the symmetric group of S3. That is the number of elements in the conjugacy class of a 3 cycle. So you need that formula. Okay, so I hope everyone studied that formula. So everyone studied my notes. So in my notes there is a formula given.
So what is the question, sir?
Yeah. So now I read the question. Oh, yeah. Fourth question. So I read the question first. The number of elements in the conjugacy class. Okay. So what is it? So the question is the number of elements in the conjugacy class of the 3 cycle. So if you take the 3 cycle alpha, so the number of elements in, actually they are asking conjugacy class, so that is CL of sigma. Okay, what is the cardinality of the CL of sigma? That is actually asking, where sigma is the 3 cycle 2, 3, 4 in S6. In S6 we fix one element sigma, and then we can define the conjugate class. That is set of all permutation which are related to the sigma, that is conjugate class. And what is the order of this conjugate class? That is a question.
This is equal to number of elements of order 3 in S6, sir.
Not exactly that one. Why? So actually, why? Yeah, tell me why.
Because in Sn elements of same order, same cycle decomposition, sir, they belong to the conjugacy class.
Yeah, they belongs to conjugate class, right? Yeah.
So if we find the number of elements of order 3, sir, like 3 cycles only.
Okay, now tell me how many 3 cycles.
So cyclic decomposition will be 3, 1, 1 and 1, sir.
Okay.
So we'll have 6 factorial by 3 into 3 factorial, sir.
Okay, so options are 20, 40, 120, and then the last one is 216. So you are saying, what you are saying, what is the formula? So maybe I can, otherwise you can directly use maybe that formula, and you are saying maybe both are equivalent. So maybe I write the formula now. Okay, so you can directly get
40, sir. Answer is 40, sir.
Okay, answer is 40. We will check now. Yeah, we know that any two, suppose both are same cycle type, that should be conjugate. We know that. Here the cycle type is 3 1
Your
1.
voice is breaking.
Okay, so voice is breaking. Now is it okay? Number of 3 cycle. Okay, so number of 3 cycle is the answer. So you know the formula for number of 3 cycle. What is the number of 3 cycle? In S6, your formula for that one, right? So anyway, so I will directly say the formula. You can apply for that formula to any permutation on any length. So what is the formula? What is the note is? Suppose if I think it is in the 87th point in my notes. Okay. So it says, suppose sigma is a permutation Sn. Suppose you can decompose the sigma into product of cycles. Suppose I am writing the cycle, this length is m1. How many times this m1 appears? Suppose k1 times this m1 cycle appear. The m2 cycle appear k2 times. Okay, and so on. Suppose this m some number s is appear k suffix x time. Okay, and what is the condition? If you just product these two number and then sum, that is mi and then m1 into k1 plus m2 into k2 plus etc. plus ms into ks should be equal to n. This is the condition. So you can include one cycle also. Okay, how many times is included? One cycle. Okay, that one cycle also you can allow it. Now then the number of elements in CL of sigma, that is number of elements conjugate to the sigma is, that is the number of elements is n factorial whole divided by k1 factorial times m1 power k1 into k2 factorial m2 power k2 and so on, ks factorial. So okay, so if sigma is this form, m cycle we have a k1 times, m2 cycles we have a k2 times, etc. ms cycle we have a ks times. The number of elements in CL of sigma is n factorial by k1 factorial into m1 power k1, k2 factorial into m2 power k2, etc. ks factorial into ms power ks. Okay, so this is a formula. Now n equal to 6 in our case because we are working S6 and the sigma should be 2, 3, 4. Okay, so the number of the 3 cycles are 1, only 1. Therefore, suppose if we take the 3 cycle is m1 is the is actually 3 cycle actually. It should be we have only 1, and then how many times it have? We have only 1 times, only 1 3 cycles. All others are 3 cycles are only 1, all others are 1 cycle. So therefore, what is the 1 cycle? Remaining elements are 1, 3 is already there. The 1 cycle is 1 and then 5 and then 6. Because this satisfy the condition, should be the product should be n. Okay, so here m1 is 3, this is a 3 cycle. How many times is repeated? Only 1 times. Therefore, what is the product of this? 3 into 1, this just 3, but we have 3, one more 3, right? So total we have 6. But here how many times the 1 cycle repeated? 1 times. So the number of m2 I am taking 1 cycle. How many times is repeated? How many times we have? We have 3 times. Therefore 1 into 3, therefore we have totally 3. Therefore we have a m1 equal to 3 cycle we have a, and the number of 3 cycle is 1, and then we have another one is 1 cycle. How many 1 cycle we have? 3 1 cycle. Now what is the substitute this everything in this formula? Therefore coordinate of this CL of sigma equal to 6 factorial divided by k1 factorial, that is 1 factorial, into m1 power k1, that is 3 power 1. into k2 factorial, that is 3 factorial, into m2 power k2. So m2 is 1 power 3. 1 power 3 is always 1. Therefore 6 factorial by 3 into 3 factorial. So therefore we can cancel 3 factorial. Therefore remaining we have 4, 5, 6, and then denominator we have only 3. So if we cancel these 3 we have 2, therefore 40. Okay, so answer is 40. Your answer also correct, because both are same answer. The same thing, because conjugate means what, both have same cycle type. You can find the number of 3 cycles. Suppose you forget to find the number of 3 cycle, you can use this formula to find the coordinate of any permutation. Okay. Okay, next thing. Okay, next we can see the form. Okay, maybe I can ask on the linear algebra. Okay, fifth question. Same type of question anyway. So we have a linear transformation from R4 to R2, R4. Okay, so it's linear transformation defined by T of any 4 elements x, y, z, w is goes to x plus y plus 5w, comma x plus 2y plus w, comma minus z plus 2w, comma 5x plus y plus 2z. This is the last coordinate. Okay, now what is the dimension of, they are asking about the eigenspace, but you should know what is the definition of eigenspace. Nothing but collection of all eigenvectors corresponding to that eigenvalue, but in the question they will not give what is the corresponding eigen thing. So anyway, if you find that, actually a question may be okay. Actually we have some mistake in the question. They ask this is the dimension of the eigenspace of T. So eigenspace of T means what? I think it's actually wrong. Eigenspace, eigenspace is nothing but, if you know lambda is one of the eigenvalue, if you know lambda is an eigenvalue, then the corresponding lambda we have eigenspace, we usually call E suffix lambda, is just notation. This set of all V such that AV or TV, so depending upon the linear transformation here T, therefore TV equal to lambda V. So we are collecting all V satisfying this equation, even including 0 also. So this form is a space, this is called eigenspace. Eigenspace of T with respect to actually lambda, eigenspace of lambda, because we fix lambda and then you have to find the, I got to define the eigenspace, but the question is they are just asking just eigenspace of T. That is not a correct thing, maybe they will miss something. Okay, we move to the next problem. You have to find the dimension of this, that is the dimension of this.
Sir,
Yeah.
is eigenspace equal to null space of A minus lambda A, sir?
Yeah. Yeah, same thing, because you can take this everything to that one side. So we get TV equal to lambda V equal to 0. You can take T outside, therefore T minus lambda I at V equal to 0. So that is we are collecting V such that this equal to 0. So this is nothing but null space of the operator T minus lambda I. Okay. But for this lambda, okay, particular lambda, so eigenspace of lambda is nothing but null space of T minus lambda I. Okay.
So if we have 4 lambdas, then we should add all the eigenspace, sir, for dimension.
So if you know,
Now, if we know the lambda, sir.
yeah, if you know the
one-
lambda, you can easily find that null space of T minus lambda I.
Okay, sir.
And if
For
you know,
all lambdas, you have to find, sir.
no, actually they will ask for particular lambda, but in the questions there is some mistake, I think.
Okay, sir.
Maybe suppose all the eigenvalues are same, then they can ask anything. Okay, the question is valid. Suppose all the lambdas are same, then eigenspace of t means okay, eigenspace of one that particular lambda, but this maybe I think we get different eigenvalues for this linear transformation. So therefore that is a question, maybe some wrong. Okay, now anyway, this is gate level examination question. Okay, maybe little harder than jam. Anyway, so that's why I pick so small examples. Now they will ask some beautiful another question, 12th question. Maybe you can say, if, because I already said that linear transformation same as matrix. Matrix is nothing but we can view it as a linear transformation. Okay, so if the nullity of the matrix, what is the matrix? This is 3 by 3 matrix, k 1 2 1 minus 1 minus 2 and then 1 1 4. Here k is unknown. Okay, suppose the nullity is given that 1. Okay, the nullity is 1. Now what is the values of k? Then the value of k is dash. So the options are minus 1 0 1 and then 2. So what is the rank of the matrix? Yes, it's a 3 by 3 matrix. Therefore, it's a linear transformation from R3 to R3. Okay, it's a 3 by 3 matrix. Therefore, it's a linear transformation from R3 to R3. It's given that nullity is 1. What is the rank? Maybe we can call this is, yeah, rank is
2, sir.
2. So rank 2, but this is a 3 by 3 matrix. Then what can you say about the determinant of the matrix?
0, sir.
Yeah, 0. Now find the determinant of this matrix equal to 0. You can find the values of k. So therefore, if you expand via this one, k times 1 into minus 4 is minus 4 and then plus 2 and then minus 1 into the second entry 4 plus 2 and then plus 2 times 1 plus 1. This is a determinant, that should be 0. Therefore, this is minus 2k and this is 4 6 minus 6 and this is 2 to 4 plus 4 equal to 0. Therefore, this is minus 2. You can take therefore, what is k? Should be minus 1, right? Therefore, k should be minus 1. This is the idea. So you have to find the determinant is rank is 2. Therefore, the determinant should be 0. From this, you can find the values of k. Okay. Anyway, this is a very simple question. Don't expect this question nowadays. Maybe jam exam they will ask like this type of question, but in the gate examination they will ask more than this. Anyway, depending upon the question setter. Anyway, now we move to the next question. Okay, now from group theory question, 13th problem. Okay, not 13. Okay, I think 6. Okay, sorry. So this is 6 and this is 7th problem. So what is the problem? Suppose G is a group of all symmetry squares. That means what? G should be symmetry, set of all symmetric matrices on square. therefore should be S4. Okay, square have 4 edges, right? 1 2 3 4. So you can rotate and then reflex, rotate and then
D4, na, sir?
symmetrices, all symmetrices.
S4 is bijection, no, sir, from set.
Yeah, that is symmetric bijection. You can say both are actually equivalent. So bijection, we can say geometry set of all bijection from bijection from the 4 element sets to 4 element sets. Geometrically, we can see if we take S3 means what? You can look at the triangle. Okay, so how we get this S3 geometrically? Actually, if you take triangle, I have 3 corners. So they fix the triangle now. So it's the identity. So nothing, we cannot do anything. Therefore 1 goes to 1, 2 goes to 2, 3 goes to 3. So that is the identity element without anything. You have to rotate this. Therefore that one position goes to the second position. The second position goes to third position. The third position goes to first position. You can rotate that like that. Otherwise, you fix this position just to rotate these two. Therefore, we get 1 position goes to 3, 3 position goes to 1, second is fixed. Suppose you fix third position and then fix these two, rotate these two. Therefore, 1 goes to 2, 2 goes to 1. Again, fix 1, you can rotate 2 and 3, we get 1 and 2. And then we can, then what is the other possible? We can rotate here, we will get this one. Suppose you can rotate this direction. So therefore the one position goes to the third position, the third position goes to the second position come to the first position. So totally we get 6 elements. Actually this is a reflection. So actually Sn is nothing but you take the polygon with the n side. Okay, Sn, how we will get the Sn geometrically? Sn, you look at the polygon with the n side. Okay, this is not a polygon. Okay, anyway, so you can take some polygon of n side. You can call the edges are 1 2 3 4 5 6 etc. up to n. Okay, you can rotate 2 pi by n angle. Okay, this is a formula. This is an angle. So you can rotate how many angles? 2 pi by n angles. Okay, and then reflect about x-axis or anything. So you will get a new thing. So the collection is called the symmetric groups. Okay, so that is G be the group of all symmetrices of the square. So therefore you can take, if it's square symbol, square picture, and then you can, we have 1 2 3 4. Therefore if you all symmetrics are is nothing but S4. The question is the number of conjugacy classes in G. The number of conjugacy classes in G. So what is that formula? We go, I think everyone have a formula. So what is the formula? Conjugacy classes in G. So the first option is 4, the second option is 5, the third option is 6, and then 7. So do you know the formula is nothing but partition of n, but here partition of 4, P of 4. The number of conjugacy classes in Sn is P of, so in Sn number of conjugacy classes is P of n. So P of n is nothing but partition of n. So how many ways, how many different ways we can write n? So here n equal to 4, therefore answer should be P of 4. So P of 4 is nothing but partition of 4. What is the values of partition of 4? 4 can be written as 4 or 3 plus 1, or we can write 2 plus 2, or we can write 2 plus 1 plus 1, or we can write 1 plus 1 plus 1 plus 1. So 5 different ways we can write. Therefore P of 4 is 5. Therefore answer is 5. The number of conjugacy classes in Sn is P of n, where P is a partition of n. Okay. So here P of 4 is 5. Now next question. Then dimension. Okay, what is this dimension of the symmetric matrices, and then skew symmetric matrices. Okay, eighth problem, that is simple one. So eighth problem, so what is the question? What is the dimension of the vector space V? What is the dimension of V, where V is nothing but set of all matrices A, the entries are A, J, is a n by n matrix. What is the condition? Aij should be equal to minus Aji. So actually what we are collecting, A equal to minus A transpose. We are collecting is a set of all skew symmetric matrices, n by n skew symmetric matrices. What is the dimension of that subspace, vector space V? So the first option is n square, the second option is n square minus 1, then third option is n square minus n, then the last option is n square by 2 over the field R. Now okay, look at this here, all the entries are from complex number, so that is also very important. Aij from the complex entries. If we take the real entries, that should be different, but they are asking vector space over R, dimension of vector space over R, but the entries, matrices entries are complex numbers. Now for example, if we take 2 by 2 matrices, but should be complex entries, and actually if you take the complex entry, that should be Hermitian, sorry, skew Hermitian. Okay, anyway, so how the matrix look like? If you take a 2 by 2 matrix, suppose I am taking A equal to, all entries are complex entries. Suppose if you take Z1, some Z2, Z3, Z4, Z's are complex number, and this should be equal to minus of the transpose. The transpose is Z1, Z2, Z3, Z4. Okay, but should be minus, therefore everything is minus. Now if we compare this coefficient, we get Z1 should be equal to minus Z1. So this is happen only when Z1 should be 0. That is the only possible. Similarly, Z4 equal to minus Z4, therefore Z4 should be 0. So if you take any skew symmetric or skew Hermitian, the diagonal elements always 0. That is the thing. So therefore now this A reduces to the matrices of the form 0, some Z2, then should be, this term should be negative of this term, and 0. So every matrix like is of the form this one. So now maybe if you take instead of Z2, simply say just Z. Z is a complex number, and any complex number can be A plus IB or X plus IY. So okay, 0. Suppose I am writing X plus IY, and this should be minus X minus IY 0. Okay. Now this is a vector space over C. Therefore the scalars are comes from R. So we can rewrite these matrices sum of some matrices. So suppose I am taking X outside, so we can write 1 minus 1 0. Suppose I am taking Y outside, we have a 0 I minus I 0. If you multiply X inside and then multiply Y inside and then sum both the thing, you will get the above matrix. Therefore these two are basis for this 2 by 2 matrix. So if you take n equal to, we get 2. Okay, therefore the dimension is 2 for n equal to 2. Now if substitute n equal to in the first option, you get 4. Therefore this is not a correct answer. If substitute n equal to 2 here, 2 square minus 1 3, that is 4 minus 1 is 3, that is not true. Now if you substitute here, maybe we will get 2, that is n square is 4 minus 2 is 2. Maybe sometimes this happen, but look at the last option also, 2 square by 2 is 4. This is also correct, but we cannot say we got to choose either C or D. We can omit A and B now. Now similarly we can work for 3, n equal to 3 case. Now if you take any 3 by 3 matrix, A is 3 by 3 matrix, and then skew Hermitian. Therefore I already said that any skew Hermitian, the diagonal should be 0. And if you take some Z Z1, Z2 and then Z3. That should be, what is the elements here? Should be a negative of these terms. So should be minus Z1, this should be minus Z2 and this should be minus Z3. Now what is the dimension? So therefore each Zi contains some, suppose I take A1 plus IB1 and this is Z2 maybe is of the form A2 plus IB2 and this should be A3 plus IB3. Therefore how many unknowns we have? 1, 2, 3, 4, 5, 6. Don't bother about this because this is nothing but negative of this one. So totally we have a 6. So if you take n equal to 3, we will get the dimension is 6. Okay. So now look at the formula now. If substitute n equal to 3 here, if 3 square by 2 is nothing but 9 by 2. 9 by 2 is not a number, it's not an integer. Therefore that is not true. Now but if you substitute here, 3 square is 9 minus 3 is nothing but 6. Therefore this is the correct answer. So keep in mind, so they are asking, they are taking entries as are complex number and they are asking dimension over R. That is a very important. Okay, you have to carefully, you have to watch the elements are comes from where and then from what is the over the field. Okay, so that is an important thing. Okay, now the next question. Okay, maybe from the differential equation we can solve one problem. 9th problem. The equation alpha times x y cube plus y cos x times dx plus x square y square plus beta times sin x into dy equal to 0 is exact for what values of alpha beta. This is exact. First option, alpha is 3 by 2, beta is 1. And then second option, alpha is 1, beta is 3 by 2. And then the third option is alpha is 2 by 3, beta is 1. Similarly, alpha is 1, beta is 2 by 3. Now how to check? So it's given that is exact, therefore here m is the first thing. So m equal to alpha x y cube plus y cos x and n should be x square y square plus beta sin x. What is dou m by dou y? Partial derivatives with respect to y. We have 3 alpha x y square and then plus cos x. What is dou n by dou x? Is 2xy square. Derivative of sin is cos, therefore plus beta times cos x. So now this should be equal, both are equal. Therefore here cos x, here we have cos x, therefore beta should be 1. And here the coefficient of xy square is 2. And here the coefficient of x square is 3 alpha. Therefore alpha is 2 by 3. So alpha is 2 by 3, beta is 1. Option C is correct. Okay. Now the next thing. Okay. Again from linear algebra. Suppose we consider the subset W is set of all matrices Aij should be 10 by 10 matrix. Okay, and the condition is Aij is 0. When this 0, if I is even. if the first position Aij, the I is even number, then that entry should be even, that entry should be 0. Okay. Now what is the dimension of, this is subspace, okay. So what is the dimension of W? So first option is 25, second option is 50, third option is 75, the last option is 100. Okay. So what is the answer now? So therefore all the second row should be 0. Now if we take any matrix, usually we can write Aij means what? A11, A12, A13, etc. Now is a 10 by 10 matrix, therefore A110, and then A21, A22, etc., A210, and so on, A101, A102, etc., A1010. Okay, it's not 100. Okay, this one. Now the second row should be 0 because the first position is, the first subscription is even number, is given that if I is even, that should be 0. So therefore this entire row is 0, and then if you take the fourth row is also 0, sixth row is always 0, the last row is 0. Therefore how many remaining unknowns are there? And then remaining we have 5 rows. So therefore what is the answer? Each row contains 10 unknowns. So the first row contains this is unknown, this is unknown, this is unknown, up to this unknown. Therefore there are totally 10 unknowns in each row. But how many non-zero rows we have? Only 5, because already 5 rows are 0. Therefore 5, 10 plus 10 plus 10, 5 times, therefore 50. 50 is the dimension. The number of unknowns in the matrix is the dimension. Got it? Now another one is simple integration. You can easily solve it. So the 11th problem, suppose the domain E is given by set of all ordered pair x comma y in R2 with the condition that x varies from 0 to 1 but y varies from 0 to x. Now what is the value of the double integral over E x plus y into dy dx or dx dy equal to? So the first option is -1, second option is 0, third option is 1, and then the fourth option is 1 by 2. So it's trivial, is given that x is 0 to 1, therefore double integral over the region E x plus y dx dy should be, first you got to write the x value 0 to 1 and y is 0 to x plus y dy dx. First you got to integrate with respect to y, therefore integral 0 to 1, if you integrate with respect to y we get xy plus y square by 2 lower limit upper limit into dx. So we get x square, and here also x square by 2, therefore 3x square by 2, 3 by 2 x square, integral 0 to 1 dx. And if you integrate this we get x cube by 3, 3 cancel, we have x square by 2, if substitute this one, finally we get 1 by 2. So this answer. Okay. Now the next problem. Sometimes they will ask about null space. Okay. Okay, maybe we will discuss one more problem and then we can stop. Okay, the final problem. 12th problem. Suppose we have a matrix A, fix the matrix A equal to 1 1 1 2 2 3 and then x, y, z. Okay, this is a matrix. This now we are collecting new, we define here V. So V is nothing but set of all this x, y, z such that the determinant of A is 0. So for what values of x, y, z, the last row of the matrix, if the determinant is 0, we are collecting the last row. Okay. So question is, assume that this is a subspace. Okay. Now what is the dimension of V? What is the dimension of the vector space V over the field R? So the first answer is, first option is 0, second option is 1, 2, 3. So now tell me, there are 3 unknowns we are in our collection x, y, z. We try to reduce the unknowns using this property. What is the property here? Determinant is 0. So what is the determinant of the matrix? A. So if you simplify via the first row, 1 into 2z minus 3y minus 1 into 2z minus 3x minus plus 1 into 2y minus 2z. That should be 0. So that is 2z minus 3y minus 2z plus 3x plus 2y minus 2z equal to 0. Now we can cancel this 2z minus 2z, the first term and the last term. And then what about the remaining thing? You can add these two, we have minus y. And you can add, I did any mistake? No. Okay, now we have only one x term. I think I did some mistake. I did a mistake. The last one is actually 2y minus, actually this is not z, actually 2x. So totally I am wrong. So that should be, this is not 2z, actually it's 2x. This is 2, I am looking, actually this is 2, not z. Okay, therefore 2y minus 2x equal to 0. Now we can cancel this 2z and then this 2z, right? And then we can add these two, we have a minus y, and then you can add these two, we have plus x equal to 0. That means what? X equal to y. Now we reduced one variable y. So therefore, this is the only condition x equal to y. In the determinant equal to 0, we get only relation x equal to y. Therefore, in the v, x comma y is nothing but again x comma z. So how many variables now? We have only 2 unknowns, x and z. Therefore, dimension is 2. Okay. So that is the only, we have to reduce only one variable using the given condition. Okay. So anyway, we can stop now. Thank you.